So when we talk about how heat moves from place to place, we say that there are three ways that that can happen. They're called conduction, convection, and radiation. So we'll talk about each of those. So the first one is conduction. And in conduction, what happens is as molecules are heated up, we know they move faster. They speed up. And so when those molecules speed up and move faster, they bump into molecules that are nearby. And then those molecules start to move faster. And then they bump into molecules. And we sort of start this chain reaction in which the molecules move faster, which increases their temperature, and that spreads through the material. But this really only occurs in solids. And some materials are better conductors of heat than others. For example, what's a good conductor of heat? Jonathan?
Most metals.
Yeah, most metals are good conductors of heat. Okay. That they rapidly conduct heat from one place to another. What about some things that are poor conductors? Joey?
Rubber.
Rubber?
Wood.
Wood?
Plastic.
Plastic? Yep. What is another word for those things? Opposite of a conductor. No? Insulator. Those are insulators. Wood, plastic, rubber. They are much more resistant to conduction than metals. Joey?
So, if you make a campfire, you use wood, right?
Yeah, but that's more because it burns, not because of conduction at all. So, everything in this room is basically at the same temperature right now. Like the chairs, the desk, and so forth. They've been sitting all night long, so they're all about room temperature, which is right now about 67, 68 degrees. But if you on the back of your chair, touch the metal part of your chair,
Whoa, it's cold.
and then touch the red or blue plasticky part, that resin material.
That's warm. This is how cold it is.
So, they're actually pretty much the same temperature. They may not feel it to your hand. Which one feels colder? The metal. Okay? But they're actually this equal temperatures because they've been at the same temperature for a long time. And the reason that metal feels colder is because it's a good conductor of heat. So when you're touching the metal, what's happening? Jonathan?
Like, it's like transferring it, or your heat is transferring into it because you have more heat in your hand.
Yeah.
Because
Your hand's much warmer. And therefore, because the metal is a good conductor of heat, heat moves quickly from your hand into the chair. That's why it feels colder. Whereas the resin part is not a very good conductor of heat, so that heat transfer doesn't happen as quickly and doesn't feel as cold. But they're actually the same temperature. Okay? The metal is a conductor, and the chair part is the insulator. And so conduction is why, when Mr. Arcuri and his wife were roasting marshmallows at a campfire, Mr. Arcuri's wife, she's pretty smart, so she grabbed a wooden stick out of the wood to roast her marshmallow. Mr. Arcuri, on the other hand, he grabbed a big metal pole to roast his marshmallow, and that didn't work out so well for him.
The left one looks like wood.
No, Mr. Arcuri's wife is happy. She's getting a roasted marshmallow. Mr. Arcuri, no, that red metal. Just he wears like a nightgown at night. He just feels that it's more comfortable and sleeping. Just don't judge him. It's okay. So a key thing to know when we're talking about conduction is that the molecules aren't moving from place to place. So Mr. Arcuri's hand didn't get hot because molecules that are near the fire went up the rod into his hand. The molecules all stayed in the same place, but as they vibrate fast, they started that chain reaction, which caused the molecules to vibrate faster all the way up, and that's what burned his hand. But in the insulators, in the wood or the rubber or the metal, that doesn't happen very quickly at all, and so they don't warm up. If you've been making chicken soup after school for a snack when you get home, and you have a metal spoon and you leave it in the soup that's heating up on the stove, it gets hot very quickly. Versus if you're using a wooden spoon, it doesn't heat up because it's not a good conductor. Jonathan?
Is that why, like, when you stick like a thing, metal thing in the toaster, it explodes?
No, good conductors, metals are also good conductors of electricity as well as heat. And we use the same terms. A conductor in electricity conducts electricity where an insulator doesn't.
Does he have a scar?
Oh, a scar? I don't know. You could ask him. All right. So heat flows from the hotter area to the cooler area. All right. The next method of heat transfer is called convection. And convection is a means of heat transfer in which the molecules are actually moving from place to place. It's caused by the movement of molecules. It often occurs in liquids and gases. And if we look at this example, if I have a large container of water that's being heated in one area, right, that water in this area that's right near the flame, tell me what happens to that water. There's probably three things we could think of. Joy, what happens? Gets warmer.
It might move to the other side of the water where it's colder.
Well, let's get to why first. So what else happens? So the molecules get warmer, which means what? They move faster.
No.
What else happens when we heat up material? It expands. And thinking back several months ago to our first physical science unit, metric system, as it heats up and expands, what also changes about it?
It boils.
Well, eventually, but before that, the density changes. How does the density change?
Because
When it expands,
it's smaller.
the density decreases. And what happens to something that is less dense than its surroundings?
It
You guys said both ones. Which is it?
floats.
It floats. So less dense object floats and it rises. So the water that's being heated up in this area gets less dense and it starts rising to the surface. New water takes its place. And then we create this thing we call convection current, where we have rising warm water being replaced by cooler water, and we have this convection cell, convection current. Okay? And it's one of the reasons when you start heating up water, you see bubbles rising to the surface. Again, it's because the water is being heated, expanding, rising to the surface, new water is taking its place. It's also why when you are at the beach, on a sunny day, you get a breeze from the ocean. It's because of convection, because the land heats up quicker, the air above it heats up and rises, new air takes its place coming from over the ocean, and you have a breeze coming in from the ocean almost all the time because of that differential heating.
Is that what thing?
Yeah, I'm going to show you that in a second. You know, if you feel the air over a heater, you could feel the warm air rising. Okay, if you in your house, if you have no air conditioning and a real hot day, the upstairs is probably much hotter than the downstairs because that warm air rises. You know that if there's a fire, that you should go close to the ground because the warm, hot, burning air and smoke rises up, and the cooler air is towards the bottom. So these are all examples of convection. The third type of heat transfer is called radiation. And radiation is the direct transfer of heat energy through electromagnetic radiation. It doesn't involve molecules at all. Right? And you've felt this many times, I'm sure. You know, if it's a sunny day, you go out and you just like look up at the sun, you can feel the heat energy radiating from the sun. If you have at your house like a fireplace, or like a gas fireplace that's enclosed, there's glass over the front, but when that fire's on, can you feel the heat coming off of it? That's through radiation. It's not molecules from the fire getting to your hand. It's not through conduction, it's not through convection, but the electromagnetic radiation from that fire goes through the glass and you could feel it. You could feel if you're at a campfire, you could just feel that heat coming off of that. That's radiation. You feel like a light bulb that's very hot. You could just sort of feel that heat coming off of that. Doesn't require any molecules. In fact, space is pretty much a vacuum, and there's no molecules, but yet energy from the sun reaches us because radiation, electromagnetic radiation, doesn't need any molecules to be transferred. It transfers directly through that energy. If we look at this example, and you have a similar picture in your notes of, if you're heating up a pot of water and stove, all three means of heat transfer are taking place. The flames are radiating heat. Inside the pot of boiling water, there's convection taking place, where you have that boiling water, where warm water is rising to the top, new water is taking its place. And pots and pans obviously are made of metal. They're made of metal so that they can conduct heat, so they can transfer heat throughout the whole pan, so that they can cook their food evenly. Joey?
Last year, my science teacher did. She took there was this like a rod with a ball on it, and then we had the rod with the hoop.
Oh, yeah?
At first she would put it through, and then she took the rod out, and then she tried to get it back.
Yeah, well, yep, you're going to use these in a few minutes.
Oh,
All right, so any questions about the